Okay, so in this problem here, we have I don't know, a little plank or board or something, and we have a stone that's a foot off the ground. And let's just give you some values here, because I forgot to give you the values again. It's 200 pounds, that plank of wood, or metal, or whatever you want to call it. I just gave an arbitrary number. The reality is, when you can use any number in these, it's just to give you a concept of it. So, first of all, let's find out what alpha is, because we have enough information to find out what alpha is, and it's much easier. So, since we have the opposite right here, and the hypotenuse, which is the 3 feet, I'm going to recommend that we just do sine of alpha equals opposite 1 over hypotenuse 3. And when you solve for that, you get alpha equal 19.47 degrees. This is a good thing to do because it takes all of the technicalities out of it, and it just gives you a straight angle. So let's find the reaction on the rock, because I suspect it's pretty high. So let's see. What is the reaction on the rock? That's what our problem will be. So we start off as we do with all problems. We have sigma f of x will equal, well, what you're finding here is that you're going to have a little bit of an angle from the rock, right? So if we were to look at that rock, we were to go, okay, and the board is sitting on it. I'm just going to exaggerate it a little bit. The board's sitting on it like this. Okay, you're going to get a force that's coming out at an angle. That means some portion of that is going to be pushing this direction, and some is going to be pushing up. The up we can deal with. What portion, I'm just going to call this Rx, is going to be going to the left? What's that going to be countered by? Well, where this board touches, there's friction. That's what's going to be countering it. So I'm just going to call that AX. And we do have an AY here as well. Okay? So, technically, AX plus RX equals 0. And that will essentially just say that AX equals RX. That's what we'll find. So yeah. That wasn't very insightful. Let's go on to the next one. We have f of y. That's AY plus RY. That's just the reaction of the rock. Minus 200 equals 0. Okay, well, as it always does, we got to go to the moment. Let's do the moment at A, okay? So, working on it that way, we just, walk our way through it. First off, we know that the distance to the centroid is going to be 2 feet in the center of the square, right? So, 2 times cosine of 19.47. So that's our moment arm, minus 200, okay? Then, plus whatever's in the middle here, we're going to have our distance is going to be 3 feet to where the rock is touching. So let's say 3 feet. Then cosine of 19.47 degrees as well. Then you have your reaction in the y direction. That's going to equal 0. The interesting thing about this is that well, you might want to just run through this with a calculator. You can make quick observations, like maybe this cosine and this cosine might be able to just cancel out right away. And you could do that right now. But I'm just going to let you do that algebra, and what you're going to find is that your reaction in the y direction at the rock is going to be 133.5 0.33 pounds of the 200. So what we need to find is what's the reaction total, though, because that's only, remember, that's only in the y direction. We have a little bit in the x direction as well, right? So I'm just going to call it vector r times what I would consider cosine of 19.47 equals ry. So if you work this on out, what you'll find is that you have r equals to 133.33 divided by cosine of 19.47. That'll equal 141.42 pounds. Sweet. This, you could actually then plug it into the y direction and figure out what your reaction forces were at the A. However, that wasn't part of the, I just wanted to know the reaction of the rock, so I'm not going to go into that. But, you know, let's follow up with this with some 3D problems. I think that might start to throw you for a spin. I do these problems, and I'm doing them in 6 minutes, so I just kind of feel like maybe if we touch on something a bit more complex, that maybe you might have more of an appreciation for the topic. Especially since we're going to be touching on maybe how to do it more intuitively in these following problems. So, anyway, I'll see you in the next video.